Hello everybody, let us discuss about some basic concepts of chemistry in this video. We know that more or less everything around us is made up of constituents of matters like atoms and molecules, right? Now what is matter? Matter is something that has mass and it occupies some space. And this matter has three different states like solid, liquid and gases. And what are solids, liquids and gases? In solids, the particles of the solids are held very close to each other. That means there is a tight packing of the particles of the solid, and because of that, the particles are not free to move around. And when we talk about liquids, the particles are close to each other, but they are not as tight as in the solids. Hence, there is some freedom for the movement of the particles. Whereas when we talk about gases, the particles are far apart and they just move around easily and freely. And the movement is also fast as well. So now, solids have definite shape and volume. For example, consider a duster or a wooden plank or something like that. They have a definite shape and volume, right? And when we talk about liquids, liquids do not have a definite shape. They have a definite volume, but what they do is they occupy the shape of the container. For example, consider you've taken 1 liter of water in a glass jar or in a water bottle. Now you see that in both the cases, the volume of the water remains the same, right? It's just 1 liter, but it's just that the water takes the shape of the container. And when we talk about gases, they do not have a definite shape, nor a definite volume. They just occupy the space wherever you fill them. And this is about the solid, liquid and gases. Interestingly, solids, liquids and gases are interconvertible. That is, solid can be changed into liquid, which can be converted into gases upon heating. And upon cooling, gases gets converted into liquid and then into solids. So this is about the nature of matter and the states of matter. Now moving ahead, this matter is classified into two different forms, that is pure substance and mixture. Now what are these two? Pure substance. As you hear the name, you get an idea, right? Pure substance means something like purity or uniformity, right? Yes, pure substance contains only one type of atoms. And when we talk about one type of particles, and when we talk about mixture, mixture contains particles having 2 or more pure substances. So these particles from 2 or more pure substances making up a mixture are called the components of the mixture. And further, this mixture is divided into homogeneous mixture and heterogeneous mixture. Now what are these? In homogeneous mixture, the particles of the mixture mix really well and they have a uniform distribution throughout the mixture. Say for example air. Air is a homogeneous mixture of gases. Or sugar solution. Consider you made a sugar solution. Whether you take a part of the solution and taste it or whether you taste the entire sugar solution, it is the same, right? Yes, this is because of the even distribution of the particles in the solution. Now the other one is heterogeneous mixtures. What are heterogeneous mixtures? When you consider something like, consider a mixture of sugar and salt. When you mix them up, you see that the distribution is not uniform throughout, and it's clearly visible, and you can actually pick out sugar or salt from the mixture. That is, it can be removed by physical methods, right? So heterogeneous mixtures are the mixtures in which the particles do not mix well and there's no uniformity throughout, and it can be easily removed by a physical method. Similarly, like mixture, even pure substances have two different classifications, that is elements and compounds. What are elements? Elements are made up of one type of atoms. We all know about atoms and molecules, right? So consider the element sodium and element copper. In case of element sodium, all the atoms of sodium elements are of one type, and in case of copper, all the atoms of element copper are of one type. But the atoms of sodium are different from the atoms of copper, right? So atoms of each element are different from one another. So when we talk about molecules, consider the molecules like hydrogen, oxygen. In all these cases, you can see that there's H2O2, right? So 2 atoms of hydrogen give a molecule of hydrogen, and 2 atoms of oxygen is giving a molecule of oxygen, that is O2. This is about elements. 2 or more different elements combine together to form compounds. Say for example, let us take a very simple example of water. What does water consist of? H2O, right? There are 2 atoms of hydrogen and 1 atom of oxygen combining together to form a molecule of water. And consider carbon dioxide as well. In carbon dioxide, we see that there is 1 atom of carbon and 2 atoms of oxygen combining together to give carbon dioxide. Now, let us discuss about the properties of matter and how it is measured. Every substance has unique and characteristic properties. This may be physical properties and chemical properties. What are physical properties? Physical properties basically includes odor, color, melting point, boiling point, etc., wherein they do not require a change in the chemical identity of the substance to measure the property. Whereas chemical properties require a change in the chemical nature of the substance to measure the chemical properties, like combustion, checking the chemical composition, acidity, basicity, etc. So this is about the physical and chemical properties. Talking about the measurement of these properties, so the SI system has given 7 base units for the measurement of the properties. These 7 base units are: for the measurement of length, the unit is meter; for the measurement of mass, the unit is kg; for the measurement of temperature, it is Kelvin; for the measurement of time, it is second; for the measurement of electric current, it's ampere; for the measurement of luminous intensity is candela; for the measurement of amount of mass, it's mole. Next, let us discuss about mass and weight and how they are different from one another. Mass is nothing but the amount of matter contained in a substance, but weight is the force exerted by gravity on the substance. So, mass remains constant wherever you go because it's the amount of matter contained, right? But weight changes from place to place depending upon the gravity. Next, we all know that the unit of mass is kg, right? Next, volume. Volume is nothing but the space occupied by the object, and usually for our convenience we use liters for the measurement of volume, but according to SI unit it is meter cube. And next, density. Density is nothing but the amount of mass occupied per volume. So density is nothing but mass by volume. Now the unit of mass is kg and the unit of volume is meter cube. Hence the unit of density becomes kg per meter cube. Next, temperature. There are 3 different scales for the measurement of temperature. One is degree centigrade, as we all use it regularly. The other one is Kelvin and the other one is degree Fahrenheit. And all these 3 different scales are related to one another. That is, Kelvin is equal to degree centigrade plus 273.15 and degree Fahrenheit is equal to 9 by 5 of degree centigrade plus 32.